All right. We should start. Does it work? Yep. Yep, it does. Okay. Good morning. Thank you for coming for so early for the first session. Frankly, if I hadn't need to be here, I would be asleep. So you did more than I intended to do. I appreciate that. We're going to talk about trust. We have a trust problem, specifically with AI, right? So that was me starting my Claude Code session. It was working for, right here, 4 hours, wrote tons of tests, amazing code coverage. It cost me some money, but you know what, worth it, looking great. And then I asked to run the app, and that's what happens. Well, okay. Why? What happened? Basically this. Anyone can relate? Happened to them? Yep, no, too early. Okay, all right. I'll try to wake you up. So yeah, this is what happens, and it's because of this. We have what I call intent to code chasm. And this is the gap between what we have in our mind that our code needs to do to what our code actually does or doesn't do in this example. So this is never trust a monkey, the chasm, the craft, and the chain of AI-assisted code. And picking up AI-generated code is not great. This is from one of the latest surveys out there, and you can see that the numbers are not great. PRs have more critical issues that they were without AI, and almost double of major issues. Interesting, very interesting paper by folks from Sonar. So Sonar, you're familiar with them, they deal with code quality. And they ask the question, can we trust the benchmarks of the coding models in terms of quality of code? So yes, we have benchmarks that claim that the models write code better and better. What if we check it with the existing benchmarks of code quality? And what they found out is that the study found that there is no direct correlation between models' functional performance measured by AI benchmarks and quality and security of generated code measured by SonarQube. So yes, the models nominally get better, but the quality of the code they produce is not. And this is what we all feel. This is another study done by Kodo that found that you can see 76% of us are in this quadrant of seeing a lot of hallucinations and not trusting AI-generated code. And who is in this quadrant here? I will wake you up. It will happen. Okay, good, good, good. So we're getting there. 76%, more or less? Okay, right. So not only the code quality is bad, it's also very dangerous. So this is another study from friends from API Arlo that found this hockey stick, skyrocketing graph of generated AI that are missing input validation completely. And on top of that, completely missing authorization. Like, obviously, that's not, most of it, it's not human written. Right? And very interesting progression that we see is that although models get better, we actually trust them less. So this is developer survey of Stack Overflow, well, I know Stack Overflow, the 5 people that are still there hate AI with passion, but still. You can see here that obviously the numbers of distrust are very high. But they are actually getting even higher. The 2025, the highly distrust number and the somewhat distrust both went up. So last year, well, the year before last, people distrusted AI. Last year, they distrusted it even more, although the models are objectively get better. So something very strange is happening, right? We trust them less, and that's from another survey from Sonar. 96% of developers don't trust AI, which correlates to Stack Overflow. We use them more. You can see the graph of adoption, and 42% already put their code in production, commit their code to production, AI-generated code, and we check them actually less, check their work. 48% of the developers always check their AI-assisted code before committing, which leaves us with 52% who does not. So almost no one trusted, almost half of us committed to production, and when we committed to production, more than half of us don't check the code. Here we go, now we're waking up. So yeah, I'm not sure how that works. I'm not sure what it says about us, but we are going to fix it. My name is Baruch Sadugursky, and I'm a member of developer relations staff at Tesla AI. I wrote a couple of books about Java. This is why I'm here, the Java champion, Microsoft MVP for AI. And the most important slide of this talk is not the previous one, is this. So if you go to speaking.jbaruch, you'll find there a page with the slides already uploaded, with the video that it's a good opportunity to check that it is recording, and it is. So probably later today you'll have the video right there. And all the links for including all the surveys and everything else is already there. It's conveniently on the bottom of every slide. You have a QR code that, while you scan the QR code, I have important stuff here to do. All right, you scan the QR code, we can continue. It's going away in 5, 4, 3, 2, 1, done. It's on the bottom of every slide. Okay, so the models, as we said, are up and to the right. They are getting better, and this is, no one lies to you, it's not marketing, they are getting better, we know that. But nothing changes. You saw the metrics of software quality and of trust. If anything, it actually gets worse, and it's definitely not getting better. And why? Why that happens? To answer this question, let's think about how software starts. Software starts in what you call software definition, software design document, software definition document, PRDs. There are many names for that. And the problem with them is that they write once, read maybe once documents. And the reason for that is that, well, there are a number of reasons. First of all, this is my favorite book, and I read the name in English. What I want to say here is that human language is extremely ambiguous. Not only between languages, but also in the same language. So documents that are expressing requirements in human language are ambiguous by definition. Not only that, not only the language is the problem, but also our mental biases. One of the most beautiful biases of human mind is the curse of knowledge. So I don't know if you ever experienced that. You come to a talk or a lecture in the school or university, and then while the speaker tries to wake up and wake you up, you kind of doze away, you maybe check your phone, and then literally 30 seconds after, you look up and this is what you see. And you're like, oh, what happened? When this happened? The problem is what is called the curse of knowledge. Once we internalize something and understood something, it becomes trivial to us in our minds, and we think that everybody else understands it. So instead of explaining it properly, we just skim through it because, well, this is obvious. So curse of knowledge is absolutely obvious to me. I don't need to explain it. You get it, right? That. So to summarize, why don't they work? Human misunderstanding and the curse of knowledge is a very big deal. Context is not shared enough. People who write those design documents, the product people, the business people, they have their understanding of what the product should do. They not necessarily share this context with developers who is going to read this document and write this product. Fuzzy responsibility boundaries, what I mean by that is eventually the product doesn't do what it's supposed to do. Whose fault is that? The product people who didn't specify it correctly, or the developers who didn't implement what was so obvious in the PRD? I'm old enough to remember this. Now, this was a sentiment like 15 years ago, and it was absolutely stupid. Who thinks it's stupid? It is stupid, because testers and QA people, they are on the same side with us developers. They help us to produce better software. This is absolute nonsense. And so that was like maybe 20 years ago. And then like 15 years ago, it was this. Right? And this is also not a thing anymore. This was solved by DevOps, of course, right? Now this is the real deal. This is present, not going anywhere because of everything I mentioned, right? So, I mean, we truly have the problem of miscommunication and the problem of trust. So the problem of trust is not only with AI. It's also with humans, it's within teams, on those team boundaries. And we know that because this is how our software looks like. Yeah, I mean, who agrees? This is like most of the time. There are exceptions though. What is like the good exception for that would be WinRAR. Right, okay. Yeah, no, but this is most of the time. Now, saying that, software sometimes works. Why does it software works despite the mistrust and miscommunication? There are a number of reasons. There are good intentions. Eventually, both product and business and us, we want to do good software. So that's it. We actually make an effort. Professionalism, we are here to produce good software, so we'll try our best to produce good software. Tests and QA, we spoke about it. Testers are our friends. They help us to produce software that sometimes works. And result observation. In the end of the day, customers will shout on us on social networks when a product doesn't work right, or even better, we actually will open it and see if it actually works. And common-ish context. We spoke about lack of enough shared context, but there is some, right? We speak with those people and we understand more or less what our product is supposed to do. With AI, there is no intentions. There is no concept of professionalism. It doesn't write tests, and when it does, it skips it, as you saw in the beginning. There is no end result observation. It cannot go and look at the product. And there is no common-ish context at all. So whatever helped us producing kind of sort of working software is now completely out of the window. None of that actually applies to code generated by AI. It's not great. And the lack of context is one of the main reasons. LLM is a stupid guessing machine that tries to guess what the next letter or word will be based on tokens. It's absolutely stateless. It has no memory. It has no session. So when you ask a pure LLM without agent or context, how do I use Spring Boot? It will say, well, what do I know about Spring? In my model, I know that it's a season, and it will tell you you cannot bootstrap a season of the year. Right? Now, this is not what you actually see. When you fire up Cloud Code and you will ask about Spring Boot, it will tell you answers about Spring Boot. But this is because you have crutches that actually make stateless model simulate a state and a memory and a context. But those are all additions that work on general context. There is, out of the box, there is no context concept in LLM. And it means that when I will ask it about your product, it will definitely not know what we are talking about. And it's actually worse because LLMs are stochastic. It means that for the same request, you will necessarily get similar but not the same response. Which is fine in conversation. It actually makes it fun because it doesn't repeat the same thing as deterministic system would be. But for the code, this is not such a great idea because code that is almost right is wrong. There is no almost compiling Java code. It either compiles or it doesn't. So what we have is infinite monkeys theorem. And you probably know that. Because of knowledge, I assume that you know it. Maybe you do. If you give infinite numbers of monkeys, infinite number of soft typewriters, given infinite time, it will produce works of Shakespeare. What we have with LLM are monkeys. We gave them GPUs, and the randomness is skewed towards Shakespeare, but still, sometimes it will get it right, sometimes it will get it almost right, sometimes it will get it completely wrong. We have monkeys that try to guess how Shakespeare looks like. So yeah, what can possibly go wrong? I mean, obviously, we will get a great software, right? Well, not so much. What we can do in order to improve quality, obviously, we have code reviews. That's easy solution. We will review every line of code that AI generates and we'll make sure that we actually have Shakespeare, right? Right? Not really. The looks good to me syndrome existed way before AI. We're busy with other stuff. We don't have time to review other people's code. We also don't like to read other people's code, which includes our code 6 months or older. And we definitely, but definitely not going to read machine-generated code. And I have a proof. How many of you ever reviewed bytecode? Well, yes, one hand. We don't review bytecode because it's a machine-generated code. Why would we bother? Now, the source code is machine-generated code. We are not going to read it. Not gonna happen. If we were asked, we will look at it, and it looks like Java, it looks okay, looks good to me, submit. So yeah, AI-generated code is terrible for software quality, and the proof that I had in the beginning is that 100% confirms it. So, my name is Baruch, and I have an obsession. My obsession is closing the intent to code chasm. How can we make sure that we have a code that's working correctly every time and perfectly captures, or as close as perfect, our intent of what we want it to do? So, there is a solution. And the solution is spec-driven development. Who heard about spec-driven development? Lots of hands. Who tried spec-driven development? Still a lot of hands. Very good. A little bit, played with it. Okay. Spec-driven development is all the rage right now. The entire industry is buzzes about that thing. There is obviously Martin Fowler writes about it, or his team at least. ThoughtWorks, put it in their technology radar, which I highly recommend using. It's in assess stage now, which is kind of go ahead and play with it, which is exactly what you are doing. Good job. There is GitHub framework from Microsoft that does spec-driven development. There is another framework that is very popular that is called OpenSpec that is also like a very hype right now. Amazon actually have an IDE that is built around spec-driven development concept, an entire IDE based on this methodology. It's a huge thing. Right, there is also one that it's the orchestrations for AI engineering from ZenCoder that is also spec-driven development. And I mean, it's legit AI practice if Andrei Karpathy tweeted about it, and he did. So legit. And the promise is we are closing we're bridging the chasm, right? So we have software definition documents or PRDs that are the prompt, and then LLM creates a spec out of those documents, and then everybody read the spec very meticulously. It's a human language, everybody can read it, product people can read it, developers can read it. This is great. And then LLM writes the code. This is the premise of spec-driven development, and it looks great. It looks like it's exactly what we need, with a slight problem. It closes part of the chasm. It goes from our intent, distills it into specs, right? This is covered. And then this. I mean, once we have the spec, then we actually give it to LLM and ask it nicely to implement it and make no mistakes. The part of the chasm from the spec to the code is not validated at all. And the problem is that we ask to implement stupid monkeys. And if there is one thing I want you to take away from this session is never trust a monkey. Monkey will do stupid things because it is a monkey. So we need to make sure that we somehow guide the monkey to write Shakespeare every time. So let's see where we have the gaps. So we have the artifact, which is the prompt, which is created by humans. And humans are subspecies of monkey. No, well, we not always should trust humans. Let's put it that way. And then there is a spec that is generated by monkeys, by our methodology, by spec-driven development, so it cannot be trusted. And then we have code that we said now go implement it, which is implemented by monkeys and obviously cannot be trusted. Duh. So yeah, so far not so great. This is President Reagan, this is Chairman Gorbachev, 1986 in Reykjavik speaking about nuclear disarmament, and the Soviets go like, sure, we will definitely disarm, trust us. I mean, we are so trustworthy. And then President Reagan goes like, доверяй, но проверяй in perfect Russian, which means trust but verify. Yes, we trust you, but let us just check. And that's exactly what we're gonna do with humans and monkeys. We are going to trust for sure, but we are going to verify. How can we verify it? Well, we can verify prompt by other humans, exactly like the Americans verified that Soviets actually did their part. Some humans are going to write the prompt and other humans are going to read it, which is perfect. Spec is still human readable. It means that whatever monkeys generated, we can still go ahead and read and double check and verify, which is also great. Now we have the code, and the code is verified by code reviews, which are look good to me because we are not going to read AI-generated code. So yeah, that's where it breaks. Still not great. Still not great. So if only there was a way to ensure that code does what we expect it to do. Anyone has any brilliant, innovative ideas? Yes?
Tests?
Well, that's no one ever thought about it, but yes, there are tests that do exactly that. That's supposed to verify that code does what we expect it to do. So the tests are natural guardrails for our monkeys. We write the test first, and then we let LLM to generate the code, and then if the test passed, the intent is captured correctly. Now this looks familiar. Anyone? Test-driven development. That's test-driven development, of course. Now, test-driven development sounds like a great idea. We have tests that is written by monkeys. And then someone reads the tests and checks that the tests are okay. And then we have the code that, although being written by monkeys, validated by our tests, and this looks like a very good verified system. The problem is we are not going to read the tests. We're not going to write the tests, we're not going to read the tests, because how many of you actually practice TDD? Be honest. Yeah, okay, that's what I thought. Right? The problem we don't practice TDD is because this is not what we want to do. We are biased for action. We came to this industry because we want the dopamines of something created and working. So when we have a problem, we're like, okay, how are we going to solve it? This is what we need to do. And we write the code. And then it works. And then we're like, ah, great, it works. Happy path. It calls happy because it makes us happy. We are not going to write the tests of the failing path before we write the test. We want to write the happy path. And we don't like to read code. We for sure don't like to read tests, because it's even more boring than reading the code. So yeah, not going to read the tests. We still have a problem. Never trust a monkey. This won't fly. We need to do better. We need to verify somehow the tests and the code without relying on code reviews. So what are tests? Tests are a lot of things. They are the setup, they are the mocks and stubs, they are the access to our code, and then there are the assertions. Those are the steps of every test. Now, what of that we need to verify? Well, not the setup, not the mocks, and not the access. We need to verify the assertions. We need to verify that whatever you saw in the first slide of assert true won't actually happen. The rest is fine. I mean, the LLM will find a way to set up the test correctly. What we need to make sure that the assertions are correct. And assertions, again, looks familiar, sounds familiar. Anyone? What the assertions and the given, when, then structure? Cucumber. What's the methodology? BDD. Exactly, right? BDD is what it is. So here's an example. User trade stocks. A scenario, given request a sell before closing trading, given that's like the setup, and then when I ask to sell 20 shares, then I should have, and I should have less of what I sold, and the sold order should have been executed. Right? So those are the assertions that I need to log. And then we're back to the question, okay, but now who writes the specs? Who will generate this code? In beautiful theory, product people and business people are supposed to write the spec, but they are not going to do it. They're not going to do it because I asked a product manager once, hey, why won't you, like, BDD was invented for you. Why don't you actually use it and write the specs? And she told me, this is a too limiting format. I'm a free soul. I want to write my beautiful PRD documents in the format that they taught us, not this spec thing. So they're not going to write it. And developers not going to write it as well. Because if developers don't like to write tests, which is code, they definitely don't write to like specs, which is not code. This is even worse. Now, TDD as an idea is absolutely beautiful. And someone mentioned Cucumber, that's like exactly the engine behind it. And the beautiful idea behind BDD is that those specs are both human readable and machine parsable in the same time. And this is very rare, because code is not human readable except of developers, which is a special breed, but code is not human readable. Specs are generally, like PRDs are not machine writable. Specs, BDD specs, is the only thing that is both. And this is critical for our goal, because using specs, we can remove the monkeys from parts of our chain that we want to verify. How does it look like? We can replace the monkeys with deterministic algorithms, and then we don't need to read any code. So this is how it looks like. We have a prompt that is created by humans and verified by humans, as we said. There is spec, which is created by monkeys, but it's okay because spec is human readable and humans can actually check it. And then there is test that is generated within Cucumber deterministically from the spec. It is generated by algorithms, not by monkeys, so we can trust it. We don't need to read it. And then we are making progress. The only thing that is left now is to make sure that code adheres to tests. The problem with that is circular verification. We ask the monkeys to validate the code that they generate using the test that they can touch. So basically, once the code doesn't work, they can go ahead and mess the tests instead of fixing the code. So how can we solve it? We can make the tests read-only. We can just make the files read-only. We can put them in the container that the monkeys cannot touch. There are a lot of beautiful ways making code read but not writable by monkeys. And it looks like it's a great idea until we realize that the tests actually must be changed to some extent in order for them to work. And you as developers know it for sure. If you ever tried TDD and you wrote a test that was failing, when you started to write the code, you actually ended up changing something in the tests. Hopefully not the assertions, because the assertions are correct, but everything else. You now have an API that the tests need to read. It didn't exist before because you didn't write it. So now you need to adjust the tests. This kind of stuff. And this is all valid changes. The only thing that is not allowed to be touched are the assertions. And locking the test files will prevent changing any of that, making the tests impossible to satisfy. So we need something smarter. And we can do that by hashing the assertions only. And we know where the assertion lives. They live in the spec. So we can do checksums, hash, and lock the assertions only, and leave everything else open for the monkeys. And it looks like we're almost there again, but there is another problem. How do we hash assertions? My first idea was, how about I create a checksum, I commit it to Git so it won't be tampered because it will be in the history, and then I will do a pre-commit hook that will check that the hashes are the same. And the monkey won't be able to commit anything. But the monkey is smart. The monkey discovered there is a nice flag in Git called --no verify. And --no verify disables commit hook. And now all my monkeys suddenly just bypass this verification. What else can we do? We can start a nuclear arm race with the monkeys. We can say, okay, we'll do the pre-commit hook, and then we'll find a way against it. And then we will put rules and say, do not touch. And monkeys, most of the time, will read it. But sometimes we'll say, you know what, I have the rule of do not touch, but I really need this code working, so I'll touch a little bit. And then we put it in the Constitution, which is the most important document in our spec-driven development ecosystem. And also, well, it's a Constitution, it's important, but I really need to commit this code. And sometimes. And then we will use pre-tool use hook in Cloud Code, which is impossible to bypass, which is true, but it's only in Cloud Code. And then we have other systems that do not work. And then we will do, okay, what about we are doing the same checks on CI as well? Now this is valid. There is no way to bypass. So we kind of pile up the defenses against those monkeys in order to keep those assertions intact. So once we did that, we have the chain. We have the prompt that is created by humans, verified by other humans, fine. We have the spec created by monkeys, still readable, verified by humans, fine. We have now the test that is generated from the spec, deterministically, we trust it, we don't need to verify it. And then we have the code that is generated by monkeys, validated by our tests, which are deterministically locked and verified, so we don't need to read the code. And here you have it. Intent integrity check, chain, from our intent to the code verified. Software definition documents are the prompt. This is our idea of what the software should look like. LLM creates the spec. Everybody read the spec and agree to it. Yes, what's in the spec is exactly what we thought our software should do. And then algorithms generate the tests. And LLMs implement the tests until the test pass. And then we know for sure, for a fact, guaranteed, that what the code does is exactly what we wanted it to do without reading the code, which is beautiful. Right? So everybody wrote text, specs are reviewed by all, software definition documents, PRDs, and specs are now living documents. They are not anymore write once, read more on maybe once. Those are the documents that we will edit when we want to make changes to our software. And everybody else is derived from specs, and whatever we cannot trust is verified by the machines, which is nice. Intent integrity chain actually makes BDD, behavior-driven development, one of the most important practices in today's era, because we define and agree on intent, and then we verify everything that AI does. We don't trust AI for what we don't verify, and this looks like we solved the problem. Well, yes, almost. One more thing. We locked the monkeys in a loop that will force them to generate the code until the tests pass. But what if they genuinely have no idea what to do? They are not lazy, they search everywhere, and they don't know the solution. We are going to burn tokens forever, because the monkeys are determined to implement the tests. And the tests are never green, because they really don't know how to solve it. This is a problem of context. This is a problem of something that only our organization knows. For example, we have a closed source library that the monkey never heard about, and it needs to know how to use it. How do we do that? We need to provide it the context. And this is an entirely different talk and an entirely different topic of context engineering. We need to tell it how to do things. And this is an example of a library, a plugin that teaches the monkeys on how to create open source contributions, how to open source requests. There are rules that we as humans know. For example, check AI policy, check previous pull requests. If they were closed because they generated by AI, probably they won't accept yours as well. This kind of stuff, behavioral stuff, contextual stuff. And you can see here the lift, the improvement. With context, it behaves 4 times better than without. And it's not because the model is weak. This is Sonnet 4.71 million context. This is the most powerful model out there. The problem is there is institutional, organizational knowledge that without plugging it in, the monkeys will just spin forever. They won't produce wrong code, we protected against it, but they will also not produce the right one until we actually do that, right? And you can see here how some of the checks are failing without context and succeed 100% with context. For example, the AI policy discovered was never discovered by the model vanilla, always discovered with context. Okay, so here we go. Generate consensus, the intent integrity chain. Features are verifiable back to the requirements. We can start trusting AI code. And this is all can only work with the proper context management. Right, so you say, okay, this is very nice. Does it actually exist? And it does. I'm going to show you a demo, not a demo, but I'm going to show it to you that it actually exists. So, where is it? Here, that's my browser. By the way, this is the show notes. And here we go. The top talk over there is this talk. It's all very meta. The slides are right there. But I came here to show you this. Right, so this is the intent integrity kit. You install it with one command. And it gives you a bunch of agentic skills, rules, and scripts that are installed in your project. And now you can start operating and asking questions like, hey, let's create a spec, and then let's create a product out of it. And once you start doing that, you will get out of the box a dashboard that will guide you through all the processes. So we start with constitution, with premise. Premise is, for example, that's like a live dashboard of a library that searches for flight, air travel tickets. And you can see that the premise is what? A library that searches for flights using whatever it uses. And then there is this constitution that I mentioned. Those are the governing principles. For example, test-driven development is a must because we want to do intent integrity check. And minimal scope, you should do it, but if there are honest requirements, that this is fine. And then we get to the spec. And those are our stories. So we have priority one, simple search. This is where we start. And then with priority two, lifecycle management, etc., etc. And we have all of that mapped between our requirements to the, for example, that's, let's see something, yeah, there's something nice, where is it, here. The library must implement manage playwright because it goes and clicks on buttons, right? So this kind of stuff. Humans are terrible in conveying intent. For that, we have at every step of our chain clarification sessions. So our agent is going to ask us questions, is going to grill us until the intent is clear. What happens when internal browser crashes mid-session? What happens when runtime initialization fails? No backwards compatibility needed in external library. Is it true or not? This kind of stuff. After the spec is done, cleared and verified, we are going to plan. Plan is technical planning. Which tools we're going to use, which context we need to provide, etc., etc. And then architectural diagram. That's a beautiful architectural diagram. It just has one block. Okay. Again, Q&A at every step. Q&A for plan. Stuff I didn't think about, like should multiple consumers in the same process share one runtime of get isolated instances? I don't know, but it's good that you asked. Let's think through it. From that, after we do a thorough checklist, we generate tests. And you can see here how every test that it generated maps to the functional requirement, and I can navigate there, not with this button, with this button. Yes, I can navigate to the functional requirements directly from the tests, and I can see for every test which tasks are going to implement this test, and the tasks will spin until the test is verified. And I know for sure that it will do it because the assertions are locked. We know the checksum right here. And from that, next thing that is happening are the tasks are generated. And you can see here the monkeys spinning until they implement the tests because they have to. And it's a Kanban board from to do to progress to implement, and you can see how every task is implemented, and the group will move to in progress and done while all the tasks are implemented in it. So that's intent integrity check that you can actually start using today. With that, this is the most important outcome of this process. We spoke about it. As you don't read the code, as you don't read the bout code, you will read the code less and less. And we need a verifiable way to make sure that the code is correct, and this is exactly what we are doing. So, as with every abstraction leap, it starts with failures and ends up with progress. We are in the midst of one, and this is where we are going. Never trust a monkey, and intent integrity. How can you make sure that our intent is preserved throughout the entire process is captured is the most important one. And yeah, so spec-driven development looks like this. We nailed the first part. We definitely didn't nail the second one, but it doesn't have to. We have ideas and tools how to make sure that this actually goes all the way. And if you want to try something Monday morning, take one feature from your backlog, your production, I don't know, your pet project for sure, and then write the spec in English or German, doesn't matter, run intent integrity kit and share the results with me. I would love to hear if that works for your process as good as it works for mine. And with that, thank you very much. Don't have time for a QA, but I'm at J Baruch everywhere. I'm here doing the interviews in the end of this hall, so come speak with me between the interviews or listen to the interviews. There are interesting people that I'm interviewing. Talk to me about context management, context engineering, and TESOL. And this is JCon, intent integrity chain. This is the same QR code that takes you to the show notes, and there is feedback in the app that it's a little bit broken. The only option that works is 5 stars, so don't even bother with anything else. Thank you very much. The link? There it is. Now it's good. Yes, that's the link.